Hey everyone, another day, another LeetCode problem. So today we're going to check 133 clone graph. So basically what this problem states is that we're given a reference node of a connected undirected graph. And what we want to do is create a deep copy of it. So we want to create another graph, which is the exact same replica of it. So yeah, that's basically what the problem is. So as we see here, they've given us an example. You can't just go ahead and return the same graph. That's not valid. You have to create a copy, which is a replica of it. So yeah, they've just shown that this is not correct. And yeah, or the graph cannot be messed up. So it has to be an exact replica. So let's just check this out. What we're going to do is what we've been given is we have a class node. And the way node is that we get to have a value for the node. And we also get to have neighbors of the node. So this is a structure that we'll keep in mind because we're going to use that to create nodes again. And here, so they have mentioned that what we're given is an initial node. So that's all we're given. And then our job is to access that node, traverse it, look at its neighbors, because we're like, it's mentioned to us that it's a connected graph. So basically, if we traverse from that node going forward, we will find all other nodes and we'll be able to replicate them and create deep copies. So here's what we're gonna do. I'm gonna consider a map. Let's call it something like node to copy. So node to copy will be, it's going to be a map, which is going to store every specific node and then like a reference to the copy of that node. And well, yeah, let's just see how it's going to work. So I will start from the reference node, that is 1 in this case. And so initially when I start with the node, I'm going to create a copy of that node if it doesn't already exist, okay? So right now we have node 1. And we want to go ahead and create a deep copy of node 1, okay? So this will be something like over here. I've created a deep copy of 1. And now I'm going to go to the neighbors of 1, which are 2 and 4. So I'll basically do a depth first search and I'll go through its neighbors. And what I want to do is, now that I have a copy of 1, I want to append the neighboring, see if 1 has neighbors 2 and 4, I want to create copies of 2 and 4, and I want those to be appended to the neighbors of this copy of 1. So once I do a DFS, again, when I go to the node 2, I'll be doing the same procedure again. I check in my node to copy. Do I have 2? And I don't have 2. So I'm going to go ahead for the node 2. I'll go ahead and create a deep copy of a node, which is the replica of the node 2. So I'll create 2, and I'm adding it to the neighbor, to be a neighbor of 1 over here. And right now I'm at node 2. And since we're doing a depth first search, I go ahead and I look at the neighbors of 2. I go ahead and I look here. And I see, does 1 exist in my map? And yes, it does. So I get the copy of the copy which maps to it. And I mentioned that in the neighbors of 2. So that gets updated in the object for that node. So yeah, I can't really show that here, but we get that. And then we look at the other neighbor, which is 3 here. And does 3 exist? It does not. The copy of 3 does not exist. So I will go ahead and create a copy of the node 3, and I will place that here, and I will make that a neighbor of 2. And now I have come to 3. And we're doing the depth first search. Again, I check back and I see that, okay, 2 already exists in our map. So yeah, there's a connection between that. And then the next neighbor here is 4. And we don't have 4. So again, we'll go ahead and we will create 4. So we're going to create a deep copy for the node 4. We'll go ahead and do that here. And then we'll map it. Then depth first search, I go to 4. I look at the neighbors of 4. 3 already exists. Add that to the neighbors of 4, and I look at 1. So I'm actually looking at this 4, right? So I look at this neighbor, yes, the copy of it already exists, so I access that. And then I look here, and the neighbor is 1. And do we have a 1? Yes, we do. So that copy of 1 will be the neighbor of this copy of 4. So yes, this is what we do. And since we had started a depth first search from 1 and we had gone from 2 here, we're going to look towards 4, which is its other neighbor. And then we see that 4 already exists. And when it already exists, we just return, we want to append the copy of it that happens to already exist. So yeah, that's what we return, and we append that to the neighbors over here. So this is basically, it's a depth first search traversal where we're creating nodes as we go. And if they already exist, we're just returning what already exists. So I think it's more intuitive once I write the code. So what I started off with was, I want to do, like, let's check a default case here. If not node, then I can just go ahead and return none and do nothing. And then I want to map these, right? So node to copy will be a hash map, which is going to consist of node and then the copy that's mapped to it. And then let's go ahead and do a basic DFS. Let's call it something like create copy for node. So one thing, again, I can check here, if not node, I can return none. But if the node exists, so if node in node to copy, then I want to go ahead and return that node to copy. I made a typo over here. Okay, then I want to go ahead and return that. So node to copy of node. So I want to go ahead and return the copy that has already been created, or else if it's not, then it means it's not created, right? So I'll go ahead, create a copy. So copy will be an instance of node where the value will be node.value. Yeah, and I want to go ahead and map this to node. So node to copy of node is equal to this copy. Okay, and now I want to populate the neighbors of this copy with copies of the neighbors of the original node. I know that sounds confusing, but let's just see what it is. For neighbor in the original one, so for neighbor in node.neighbors, I want to go ahead and append that to this. So I will do copy.neighbors dot append. So I want it to return the copy of that. So we will basically call a create copy again. So it means that my create copy, this is in the case where the copy already exists and it's gonna return what's in the hash map. But in the case that the copy was not existent and it went and created a copy and it had no further neighbors, so it has to return copy itself. So yeah, that would be what's gonna come back here. So I want to append create copy of that specific neighbor. All right, so this is the DFS function that's basically gonna go ahead and create everything, and I can just do return create copy of my original node, and if I haven't done anything wrong or made any typos, this should ideally work. Okay, and it does work. Yeah, so the time complexity here is we're going through, let's say V is the number of vertices here, and we have E to be the number of edges. So if that's correct, then I believe the time complexity is O of V plus E. And yeah, so we have our space complexity is also going to be the same space as this. So it's V plus E, and we also have a recursive stack. So so that would be O of V, but I think the dominating term here is O of V plus E, and that's going to be the overall space complexity. So yeah, this is the explanation, and I hope you guys understood it. So yeah, happy coding, everyone.